So your field of view is the angle over which you can see. Normally it looks something like this. And so we have a field of view of this angle coming out of our eye. Now it can be changed by looking into a mirror, as we can see from these diagrams. The incoming light will bounce off the mirror and into our eyes. And so the angle here shows what our field of view would be like. If we were to project our field of view into the mirror, it means that we could see this section of the world inside the mirror. So in the case of a plane wave, our field of view doesn't change. When we look into a mirror, we don't see any distortions. We see exactly the same field of view as we would if we were looking through a window. But if we look into a concave mirror or a convex mirror, we have quite different fields of view. Concave mirrors produce a smaller field of view because only the light that's coming from this section over here will actually bounce off the mirror and reach your eye. If there's a light source over here, it will never reach you because it will come down to the mirror and it will bounce back off. And so instead of going into your eye, it will go back out here. What this means is that when you look into the mirror, the only things you can see objects in this area. For a plane mirror, you have a bigger field of view. You can see anything in this area instead. And of course, this area is the same as if you were looking straight forward, the same distance. But what about a convex mirror? Here, as we can see, even when light is coming from a source all the way off in the distance, it can still be reflected to our eyes. That means that we can end up seeing a field of view where anything in this area is reflected by the mirror. And as a result, for a convex mirror, we get a much wider field of view. However, this also makes everything inside the field of view look smaller than we would expect. Do images reflected by a convex mirror look smaller or larger than normal? Well, if we think about how the waves of light bounce off, even a large object being reflected by a convex mirror will look quite small because it has to be reduced to the size of the mirror. So, image reflected will look smaller than the true object. Part B. What effect does this have on the field of view created by such a mirror? Well, let's think about this for a moment. Suppose we have a forest of trees with lots and lots and lots of trees. Each of these trees will be reflected smaller in the convex mirror. This means that if we're looking into the convex mirror, we'll be able to see more trees than when we started, simply because they're all smaller and closer together. Now, if we can see more objects, that means we can see a larger part of the forest. What this means is that we have a larger field of view if we look into a convex mirror, because the objects in a convex mirror look smaller than they actually are. So what do two different fields of view look like? Well, that brings us to the next question. Which of these two pictures shows a bigger field of view? We can assume that both of these pictures were taken with the camera the same distance away. Well, not really taken so much as rendered. They're obviously digital pictures. So let's look carefully at these pictures. We can see that the objects in the left picture are a little bit smaller than the objects in the right picture. So what this means is that in the left picture we can see a larger area than we can in the right picture. The right picture is a little bit zoomed in, so to speak. So objects in a large field of view appear to be smaller than if they were in a smaller field of view. Now, because in the left picture the objects are smaller, this means that it must be the picture with a larger field of view. So the left picture is the correct answer. The light from a tree bounces off a concave mirror, passes through the mirror's focus, this dot over here, and is projected onto a screen. Draw what appears on the screen. So to answer this question, we'll need to see where the rays of light go. We have a ray of light coming from the top of the tree and a ray of light coming from the bottom of the tree. So what will happen when these rays of light strike this concave mirror? Well, if we use our law of reflection and we draw a normal over here, we can see that the reflected waves are going to bounce inwards, right? And they'll end up on the other side of the normal. The question tells us that the light waves go through the mirror's focus, so they'll end up looking something like this. Of course, the wave on top will bounce downward. So what will happen when the image forms on the screen? Well, the bottom ray of light from the bottom of the tree will be reflected to the top of the screen, and the top ray of light from the top of the tree will be reflected onto the bottom of the screen. So the reflected image will look something like this. We can see that it's upside down because it's been reflected by a concave mirror. So that's the end of the questions. In this section, we've learned about concave mirrors, convex mirrors, and the fields of view that are given by each type of mirror. In the next section, we'll be looking at some of the applications of these different types of mirror.